All right, Akim, Yuri, Diva, Joanna, Brandon, G, Maria, Artem, Alexandra, Melanie, Evelyn, Simone, Nadine, Gabriel, Alexandra, Foster, Jordan, Caitlin, Tariq, Sade, John, Christopher, Brianna, Justin, Santiago, Chevanice, Jenna, Gerlon, Stevie, Linda. What's your name? Thank you. All right, first, does anyone have any questions about anything? Any questions on anything about the geometry stuff? Did you watch the videos? Don't lie. Struggling? What's the matter? What do you have questions about? C2? Well, no, let me look right now real quick. And if I can say it quickly. All right, you said C2, was it? What did you have a question about? So like, if you have a triangle, and I draw a line like that, okay? Like we're continuing that line. Then, like, let's say this is A, B, and C here, right? We know that the measure of angle A plus the angle B plus the angle C must be 180 degrees, right? But like this number here, like let's say this was 60. This part has to be 180 degrees also. In other words, that has to be 120. Does that make sense? So then if this is X, this has to be 180 minus X. But these two here also have to add up to 180 minus X. Does that make sense? All right, so now this isn't really that good the way they wrote this. It's kind of hard to read what this is saying. But I guess this has to do with here, okay? So then that would mean that this plus this has to be equal to this. Does that make sense? And then it's just, all you do is 99x plus 2 plus 29x equals to 131x plus or minus 1, whatever. So then this 29 plus this is 128x. And this is 131x. Then this would be like plus 3 if we add the 1 here. And subtract this, you would get 3x. So x is 1. Does that make sense? Then it says find BCD. So BCD is this. So therefore it's 130. Because you plug the 1 back in. Does that make sense? So that's just knowing definition. So like all you gotta do is say that closed means it like starts and finishes at the same place. Simple means it doesn't cross over itself. Okay? So like this is neither simple nor closed. This one's closed, but it's not simple. This one's both closed and simple. This one's both closed and simple. But it's just the definition. You just need to know what the definition is. So like simple can be drawn without lifting the pencil from the paper, without passing through the same point twice. So it's like continues the whole time. You can't cross over itself. And then closed just means that it has the same starting in it. Does that make sense? It's literally, it's easy to forget what they are, but that's all you have to know. I'm not gonna say I don't forget what they are, but you know. Other question on any of this stuff? Does that answer your question? Well, the way it defines trapezoid is it says trapezoid, it has exactly one pair of parallel sides. That means it can't be a parallelogram because a parallelogram means that 2 pairs of parallel sides. So like, I think they usually make like this chart. It's like they'll write quadrilaterals here, then trapezoids, then, and I know I made this on the video, parallelogram. Then this is like rectangles and rhombus. And then this is square. So trapezoids are not parallelograms. They have exactly one pair of parallel sides. Parallelograms have 2 pairs of parallel sides. But a rectangle has 2 pairs of parallel sides, so it's a parallelogram. A rhombus has 2 pairs of parallel sides, so it's a parallelogram. Square has 2 pairs of parallel sides, so it's a parallelogram, etc. Does that make sense? Question? Just the 3. So it won't really mess up your grade very much at all, because don't forget also at the end, I'm going to curve the scores a little bit for the homework assignments. So it should still be fine. Question? All right, well, since everybody's so talkative, let's go on to the next stuff, because this is really the stuff we've kind of been building up to like the whole time. The geometry thing, I do find some people have trouble with it, honestly, but the thing is that for the people that go through the actual unit and do the homework assignments, they tell me it's usually one of the easier units for them, right? So there are some people that don't go through it and then they forget the formulas or something like that, but otherwise I do find it's pretty easy. Also, if you go and watch that video that I posted, the second one, it does go through how to do the volumes and areas, and I do explain like every formula and where it comes from. And I'm just telling you, it's much simpler to actually just know how the formula works than it is to actually use the formula sheet, believe it or not. All right, because almost all of the formulas are the exact same formula over and over and over. It's just they just kind of change the shape. The idea is the same. So it's because I just remember when I was in college, this teacher gave us all these formula sheets, and I went to go take the test, and I knew which formula was the right one, but like it had two different variables in there, and I didn't know which one was which with respect to what they meant. So I picked the wrong thing, and then I got it wrong. And my point just is that if you don't understand what the formula is, a lot of times, even given the actual formula, you're probably not going to be able to use it correctly. Does that make sense? All right. All right. Does anybody have a question about anything? All right, then this next unit is about counting and probability, right? So the reason why I think this one's kind of important is because a lot of students who take this class should be taking STA 2023 afterwards, and this is the same stuff you have to do in that class. So if you get it here, you really can't have too much issue with the other one. And this is a little different than some of the other stuff, so I feel like it's good to spend a little bit more time on it than compared to, let's say, the geometry, right? In this chapter, counting means, because like if that was what you had difficulty with, and that's how long it's going to take me to explain it to you, like, go watch the video and just ask me, and then we'll be done, But I can't teach you this like that, all right? Or I guess I could, but I don't trust people to watch the videos. Let's say that. In this chapter, counting means finding the number of objects with certain characteristics. I mean, just counting. What does counting mean? You know what counting is, all right? You don't need this definition. All right, list the different outcomes to tossing a single fair coin. So what would the outcomes be in tossing a fair coin? There'd be two total outcomes, but they say list the different outcomes. So they mean actually heads, tails, whatever. But two is the only part that really ends up being important afterwards. So that is important, right? List the number of outcomes of rolling a single failed die. Now it says number 6. All right. Now you will see, I will ask you questions later, and I will ask you that exact same question. People will be like, I don't remember. All right. It always starts off with something very, very, very basic that you have to count. You have to always be able to count that basic thing. Then afterwards, we start using that and combining it with some other stuff, right? When counting the number of outcomes for a two-part cast, you can use systematic listing. Sometimes it's easier to list all the outcomes using a product table and then pick the outcomes you want. This is really just another format of systematic listing, so it's not really that crazy. But I like writing usually something like this one, let's call it X1. This one, we'll call it X2, where X1 is the value of the first die and then X2 is the value of the second die, all right? And we roll 2 dice. Does that make sense? All right, now X1 could take on values, what, 1 through 6. X2 could take on values 1 through 6. Is that correct? And then we could write out all the different possibilities. We could get a 1 and a 1. We could get a 1 on the first one and a 2 on the second one, a 1 and a 3, a 1 and a 4, a 1 and a 5, a 1 and a 6, and then so on with all of these things. We could then get a 2 and a 1, a 2 and a 2, a 2 and a 3, 2 and a 4, 2 and a 5, and a 2 and a 6. All right. Does that make sense? Now you say, like, why would I need to bother with this type of thing? And my answer is, this is just a simple type of exercise representing 2 variables, right? And I can ask you a fairly simple question, which is involved with, playing a lot of these games, these gambling games. And I'm telling you, if we don't write it out this way, I don't think you're probably gonna have a bit of difficulty. Well, you might be able to get it right, but it's gonna take you a lot longer than it probably should. Right? So let's say I say to you, what's the probability that you end up saying the sum of the two dice is, I don't know, 9. All right? What does probability mean? Chance. So this just really just means like the chance that the sum of the two is equal to 9. Again, assuming that these two dice are fair, right? I'm not cheating or something, right? So probability just really means like the number of ways that we can get the sum to be equal to 9 divided by the number of ways that really, I guess, like anything could happen. So it ends up being 2 counting problems. Does that make sense? Does that make sense? So the next unit is about probability. So this is why we have to know how to count first to do that one. All right. All right. Usually it's always easier, or the first thing you should usually think about is what's the total number of ways? What's the total number of ways in this case? Not to roll 2 dice. What's the total number of ways here? 36 is correct. Why do you say 36? 6 times 6 is correct. I mean, I didn't finish writing this, but there definitely were more choices here, or more possibilities. Is that correct? All right, so the total number of ways are 36. Is that right? Does everybody see that? 6 times 6. And actually, we've talked about this a few times, believe it or not, already. But we've talked about, we said that there was something called Cartesian product, which was like A cross B, right? I said the number of elements in A cross B is equal to the number of elements in A times the number of elements in B. Is that right? Because if we said that there was like A many ways here, and B many ways there, there should be A times B many ways here. Is that correct? Does that make sense? So here there's 6 choices for the first thing, 6 choices for the second thing. Therefore, we should have 36 total ways. Is that right? All right. What are the number of ways that are favorable to this event? What are the number of ways that we can get the sum to equal to 9? What you say? More than 2. 4 is correct. 3 and 6 is 9. What is this? 4 and 5 is 9. 5 and 4 is 9. And 6 and 3 is 9. In other words, there's a 1 out of 9 chance that we would be able to get this. Does that make sense? Question? But writing all the things out like this is making it me able to do this fairly easily. Does that make sense? So the whole point is that he's calling this systematic listing, or this is using a product table, because we're just writing out all the different ways that this thing could happen, writing out all the different ways this thing could happen, and then, well, you combine them. Is that correct? Does that make sense? Akamori, question? It's not out of 9. It's just that there's a 11.1% chance that this happens. That just happens to be what the fraction is. I mean, I probably could think of something here when it's out of 9, but honestly, it's not worth it. The point is that this is approximately equal to 11.11%. Does that make sense? All right, and how many ways can the thing sum up to 5? What you say? Write down the table. Come on. Because it doesn't help if I can write it down. It helps if you can write it down. Four is correct. What are the 4 ways? 1 and 4, 2 and 3, 3 and 2, and then 4 and 1. And I'm systematically just listing them out. Is that correct? And how many ways can the sum be a composite number? What does composite mean first? What does prime mean? Yeah. What does prime mean? Well, composite is sort of the opposite of prime, but what does prime mean first? That can only be divided by itself, and 1 is correct. That's greater than or equal to 2. All right. So a prime number means it can only be divided by itself. A composite number then means what? If a composite number is not prime, like he was saying, what would it mean? It means it could be divided by more stuff other than just itself. Is that right? You understand? So which sums would be composite numbers first? What are the numbers that we could get that could end up being composite? 4, 6, 2 is prime. 8, right? 10, and 12. Does that make sense? Does that make sense? So then we would have to find out how many ways there are to do each of these. How many ways are there to get a 4? What'd you say? 3. Come on, write out the table. All you have to do is write 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, right? You guys understand this is 3? 1 and 3, 3 and 1, 2 and 2. Is that right? How many ways are there to get 6? Five. You 1 and 5, 2 and 3, 3 and 2. Wait, 4? 1 and 5, 2 and 3, 3 and 2, 4 and 2. No, 5 is correct. All right, so then 8, 5, And then what about 10? 3, 12, 1. So therefore, we end up getting what, 16, 17 ways. Does that make sense? Do you understand? Determine the number for which the sum is between 3 and 9. Now just be careful with this when they say between 3 and 9. That was the thing I wanted to make sure everybody pays attention to. So it really means that it has to be between 4 and 8 inclusive. Okay. Now, the way I would do this though is not do it by counting it all up directly, because there's a lot of crap that's here and the stuff that's missing. There really isn't as many. Does that make sense? Does that make sense? So what I'm going to do is I'm going to count the ways that this doesn't happen and then just subtract it from the total. What's the total again? How many total ways are there? 36. So it should be 36 minus something. How many ways can you get a 2? 1. Only can get a 1 and a 1. How many ways do you get a 3? 2. Is that right? How many ways can you get 12? 1, 2, 3, 4. Does that make sense? So it's just 3 is 3 is 6 is 10 is 13. So we get 36 minus 13, so we get 23. Does that make sense? You could do it the other way also, but there's less stuff to count this way, so it's better, I guess. Determine the number for which the sum is between 3 and 12 inclusive. Now, I definitely wouldn't count all of them. All right, you tell me what you get for the answer. We just pretty much just did it. Say it one more time. Between 4 and 11, that's right. So well, how many would there be? 34? No, close. 32 is correct. So 1, or excuse me, 2, there's one way to do it. 3, there's 2 ways to do it. Then 12, there's one way to do it. So we have to subtract 4. So it's 36 minus the 4. So we get 30 duper. Does that make sense? Does that make sense? All right, like this, I don't really, I mean, I guess, whatever. It says construct a product table showing all the possible 2-digit numbers you can use from the following set. What are all the possible first of all, how many 2-digit numbers could we select? And then what are all of them? If it was this stuff here. What would you say? What's the smallest number I can make first? What did you say? What did you say? I couldn't hear you. 2 digits. 10, no, there's no 0. 13, you can pick something smaller. 11. Then what? 13, then no 15, there's no 5. 17, then 31, 33, 37, 71, 73, 77. And then this is really a product table that I just made anyway, because all I really did was I just pretending there was a first number and then second number. The first number could be a 1, a 3, or a 7. Second number could be a 1, a 3, or a 7. So we would get 1, 1, 1, 3, 1, 7. 3-1, 3-3, 3-7, 7-1, 7-3, 7-7. Any question? Is that okay? Okay, whatever. So there's some club here. Let's just say it's A, B, C, D, and E. Assuming all the members of the club are eligible, but then no one can hold more than one office, list the number of ways that they could elect both a president and a treasurer. All right, I don't want to list them all. I want to know how many ways. We've done enough listing. How many ways could we select a president and a treasurer from these people? People A, B, C, D, and E. You understand my question? So we're gonna pick a president and a treasurer, right? There's 5 people there. I want to know how many ways could there be a president and a treasurer, right? $33? Definitely more than that. Because I mean, like Anthony could go with Ben, Anthony could go with Cindy, Anthony could go with Douglas, Anthony could go with Edith. Is that right? That's already 4 ways. And that's just saying Anthony is the president. Then I could switch all those. So that means there would be at least 8 ways just using Anthony alone. Because Anthony could be treasurer. Does that make sense? What's she say? Nope. No, we got a lot of numbers so far. Should try and write it down. So try and systematically write down all the different possible ways. Does that make sense? And I was kind of just showing you how to do it by saying like Anthony first, right? But try and write a product table. Sorry? 20 is correct. How'd you get 20? That's correct. So there are we have to pick a president and a treasurer. Is that correct? And I think I said before that I like writing out things with these slots. Is that right? And I said something like, when we're considering like doing one thing and then doing something else, we end up multiplying the number of ways you can do them. We saw that with our product table from before. Right, you ended up multiplying here. Is that correct? So how many ways are there to pick a president first? What would you say? 5. There's 5 possible presidents we can select. Is that correct? Now, given the fact that we selected a president, how many treasurers can we pick? Oh, for FOPO. So we get 20. Does that make sense? Now, why is this somehow something that you should be able to do? Because we talked about writing out these tree diagrams before also. Is that right? And if I say, who can you pick first? Well, I could pick A, B, C, D, or E. Is that right? And for each of those people, there would be 4 choices. Four choices to select for the number of people you could then pick for treasurer. Does that make sense? So 5 times 4. Is that right? Question? You understand? Assuming all members are eligible, but that no one can hold more than one office. List the different ways. So I actually did just list all the ways also here, if you think about it. All right. List the different ways that the club could elect a president and a treasurer if the two officers must not be the same gender. All right, gender. Let's assume this is male, female. Douglas, what do you want, male or female? Male. Edith, female. I think that was like my grandmother's name, but the great grandmother actually, but the so now what? Again, I don't want to really list them. I want to count them. Does that make sense? So how am I going to count the number of ways that the club could elect a president and treasurer if the officers must not be the same gender? And there should be some way that you immediately start thinking about to break the problem down. Which two things do we have to count? What do you mean? I mean, we need that, but I guess I already did that part, right? I mean, there's still something that we have to break this problem down into two separate problems to figure out the answer. Sort of. What two things do we need to count? If you were going to try and list all of them out, what would be the two ways that you would start breaking down how you would start listing them all out? Well, we need a president and a treasurer, sure, but what do you mean? Well, you're saying a lot of what I want you to say, but part of it doesn't make any sense in terms of the question. So like the thing is that it says, but must not be the same gender, right? So we actually we do need to start counting like men and women somehow. But the thing is we need to first, let's start saying maybe we make the men the president, see how many ways we can do it. Then we make the women the president, we see how many ways we can do it. But the men aren't going to get paired up with more men, right? Okay. So first I would say I need to count the number of ways that men can be president. Does that make sense? Do you guys get it? Okay, so we need to count up these two things. All right, so how are we going to count up the number of ways that the man could be the president and then the female could be the treasurer? What would you say? How many slots do I need? We need a slot for president and we need a slot for treasurer. How many presidents could I first pick? 3. There's 3 men. Is that right? Given the fact that we have a man selected as president, how many treasurers could I pick? 2. Does that make sense? How many slots do I need for the next one? 2. What am I picking first? president. And then how many of those people are there? 2, because now the president has to be a woman, so there has to be 2. Is that correct? Then what? Given the fact that we have a president who's a woman, how many treasurers could we pick? 3. So we get 6 plus 6 or 12. Does that make sense? Now you could just write them all out, of course, but if there was more, I don't want to write these out. Like I'm definitely gonna make a mistake. Does that make sense? Question? Now he says you should write a tree diagram. 3 fair coins are tossed. All right, 3 fair coins are tossed. How many different possible outcomes are there with respect to the outcomes on each coin? Now you flip 3 coins. How many different possibilities are there? Write them all down. And this should start reminding you of some stuff we did with the logic stuff. When you do this. So you can get either heads or tails for each one, right? Sorry? Nope. Write out all the possible ways and then tell me how many there are. Nobody else has an answer? There's no way you wrote out 12 different ways. Guessing. Eight. No, eight's correct. He's at 6. Ocho. All right, but guys, come on. All right, so what did we say before when we had like P, Q, and R? We said that each one could be like true or false. Is that right? So we could have what? True, 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 false. True, false, true, true, false, false. Then we could have, what, false, 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 false. This was true, 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 false, false, true, false, false. There's 8 different ways. Is that correct? What if I just change them to saying this is the first one, this is the second one, this is the third one? And then instead of writing T, I write H, and instead of writing F, I write T, like for heads and tails. Does that make sense? Because effectively, this is saying you have three variables, each one has 2 choices apiece, right? Now we're dealing with 3 coins and you have 2 choices apiece. So if you have 3 coins and you have 2 choices apiece, we should have 8 total ways. Is that right? First one could be heads, second one could be tails. This could be what? Then heads or tails. This could be heads or tails. Then this could be heads or tails. This could be heads or tails. This could be heads or tails. And then this last one would be heads or tails. And that's all the different possibilities. Is that right? Does that make sense, guys? We've done this before. Does that make sense? So there's 8 total ways there. All right. Again, A, B, C, D, and E. Assuming all members are eligible, but no one can hold more than one office, list a different number of ways that a person could elect a president, secretary, and a treasurer. If the president must be a man and the other 2 must be a woman. They're sexist now. President has to be a man. All right. How many ways? How is this going to be? This one's easy. Any way you try and do it, this one's easy. There's just not that many ways. What'd you say? 6 is correct. President, you have 3 choices because there's 3 men. Then for the secretary, I guess you have 2. There's 2 women. Then once you picked one of the women, there's only 1 remaining. Therefore, you have 6 total choices. Does that make sense? You understand? Question with this? Or just write out the tree thing. You have for the president, you can be what? A, B, or D. Is that right? Then given those 3 people, you got to pick a woman. So you can, for A, you could pick, I guess, Cindy and then Edith, or you could pick Edith and then Cindy, excuse me. Does that make sense? So it's 3 times 2 is 6. Does that make sense? Back to the club. List the different ways the club could appoint a committee of 4 members when there are no restrictions to select the committee. Are you serious? Okay. Do you understand what they're asking now? The order doesn't make any difference. They just want to pick groups of 4 effectively. Does that make sense? Do you understand what I'm saying? Now they just want you to write them down. So that's what I would try to do first. for this one, right? So I would start with like Allen, then go from there. Does that make sense? Of course, I wouldn't write Allen. I would just write A, B, C, D, and E, and F. What would you say? You have an answer? No. It's close, but no. It's actually much less than that. But again, try and write them out. Then you'll understand. If you don't write them out, you're not going to be able to do it. So I would write A, B, C, D, A, B, C, E, A, B, C, F, and just keep going. Does that make sense? Yeah, but if you can't do that, how are you going to know how to count it? First, you got to at least understand what they are first. Does that make sense? And that part shouldn't be that confusing also, because you just do like A, B, C, D, and all those rest of the ones I just mentioned. Then you don't do A anymore, right? You just did everything with A. Does that make sense? So you got to get rid of using each thing. Then you just keep, it becomes less and less and less stuff to write up. Right. More than that. Nope. Closer though. Too many. I'm guessing 15 is correct. All right. So if I start writing them out, A, B, C, D, A, B, C, E, A, B, C, F. Now I've written everything out when I write A, B, C. So then I change the C to a D. A, B, D, E, A, B, D, F, A, B. Then I can't write anything else with a D. So I write A, B, E, F here. Now I can't do A, B anymore because I've written everything with A, B. Does that make sense? So then I do AC. So ACDE. Whoops. Oh, that would have been intelligent if I did it that way first. ACDE. Then we could do ACDF, I guess. Then we could also do ACEF. Is that right? Now I can't do anything else with rather than A starting it. Does that make sense? Then it's BCDE, BCDF, BCEF. Then we could do nothing else with BC starting. So then it could be BDEF, and then that's it. We can't do anything with B. Does that make sense? Then I guess we could do CDEF. And then I think I'm done. I'm missing one. 9, 13, 14. Yeah, I'm missing one. See, this is why I don't like doing it this way. A, B, C, D, A, B, C, E, A, B, C, F. That's right. A, B, D, E, A, B, D, F, A, B, E, F. Okay. A, C, D, E, C, D, E, A, C, D, F. Good. A, C, E, F. I forgot A, D something. Yeah. A, D, E, F. I forgot that one. All right. 15. Does that make sense? Does that make sense? Now, again, this drives me insane though. Okay. So now how can we count it using the exact same stuff that we just said before? Well, so this one gets a little bit more confusing on how to do it. All right. But what you could say is that there's 4 things. Every time you pick 4, you're automatically not picking 2. Is that correct? You're like excluding 2 each time. Does that make sense? So why don't we just count the number of ways we can pick 2? Groups of 2. If I exclude the groups of 2, then there's groups of 4 left over. Does that make sense? So how many ways can we pick groups of 2? Well, first, let's just count the number of ways we can pick 2 people. Does that make sense? So that would be 6 times 5. Is that right? Does that make sense? Now, the only thing is when I'm doing 6 times 5, I'm letting anybody be the first 6 and then anybody else be the second 5, right? But like if I picked person A and then person B, and then I pick person B and then person A, it's really the same group. Is that right? You understand? Does that make sense? So what I could say is that every single time I'm picking a person and another person, I am allowing them to be switched right now. Therefore, I just divide this by 2. So we get 30 divided by 2, we get 15. That's the correct answer. Does that make sense? So like, you should, what I don't like about the way they wrote this exercise is that they should be giving you smaller sets of numbers first. Then we do it like this. So anytime you get something and you're a little confused on how to do it, try and make the set smaller. Does that make sense? So then let's say we wanted to do like, I don't know, A, B, C, D, E, and I wanted to pick groups of 2, whatever. Does that make sense? All right. If I pick groups of 2 here, fine. I can do what I'm saying right now is I'm saying we could do like A, B, A, C. If we do A, B, A, C, A, D, A, E, B, A, B, 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 C, B, D, B, E, etc. These I shouldn't be counting because I can't really pick them at all right now. Does that make sense? Then So this is what I was just calculating effectively, right? I was saying there's 5 choices for the first one, and then there's 4 choices for the second one. And I'm saying there's 20. Does that make sense? But if I count these 20, every single time there's an AB, there's a BA, right? Every time there's a CA, there's an AC. But those are the same groups. So I need to divide this by 2. Right. Does that make sense? Question? Now, the other way I could do this is I could say, let's actually count the 4 people. All right. So if we actually count the 4 people, there would be 6 times 5 times 4 times 3 ways to count the 4 people. Is that correct? Is that right? But now every time I count 4 people, so let's say I count A, B, C, D, right? I'm letting there be all different combinations of that. Does that make sense? So I'm letting there be A, B, C, D, A, B, D, C, A, C, B, D, A, C, D, B, whatever, all these. Does that make sense? Do you understand? But now all of these end up really just being one way now, or one group. So I need to divide them out because this is way too big for the answer. Does that make sense? So what do we divide out? We say that if there's 4 things you're selecting, how many different ways could you line up these 4 things here? Well, what you would be able to say, I guess, is there'd be 4 times 3 times 2 times 1 ways. Does that make sense? If you have A, B, C, D, you have 4 choices for the first one, you have 3 choices for the next one, then 2, then 1. Is that right? We need to divide that out. It sounds like that's going to be hard. It's not. If you just cancel, then you get the exact same thing I just said. 6 times 5 over 2. 15. Does that make sense? Does that make sense? Did the 6 times 5 times 4 times 3 make sense?
Yeah, the bottom part.
So you pick 4 things, okay? Let's say they were A, B, C, D, and D, okay? Now I don't want to write this out, but I'm going to, all right? I could do A, B, C, D, A, B, D, C, A, C, B, D, A, C, D, B. Okay, so then we can do A, D, B, C, A, D, C, B. Okay, I think I'm done with the A's now. Does that make sense? Then B, A, C, D, B, A, D, C, B, C, A, D, B, C, D, A, B, D, A, C, B, D, C, A. Okay, this is fun. C, A, B, D, C, A, D, B, C, B, A, D, C, B, D, A, C, D, A, B, C, D, B, A. Okay, D, A, B, C, D, A, C, B, D, B, A, C, D, oop, that's not a D. D, B, C, A, D, C, A, B, D, C, B, A. I'm done. Yay, I don't want to kill myself anymore. All right, so then this is the reason why a person learns math, because they're like, I don't want to do that anymore. And whenever it became important in some situation, I screw it up. So I need something else. Okay. So how many ways would there be to do this? Well, there's 4 distinct objects. Is that right? So we have 4 choices for the first one, 3 choices for this one, then 2, then 1. Is that correct?
Yeah.
There's definitely 24 ways here. Is that correct? 6 by 4. Is that right? So this is only when I picked A, B, C, and D. Is that right? What if I picked like A, B, C, and E? Well, there would be another 24 ways. Is that correct? Does that make sense? But those 24 need to become 1. And these 24 need to become 1 because they're all the same group. Does that make sense?
Yeah.
So whatever the hell I was counting over here, I was counting 24 times too many. So I'm dividing by 24 to get the correct answer. Does that make sense? Okay. We're gonna do more of that. So it's not like that's the end of that, okay? But that idea that I'm talking about is the only complicated idea with all this stuff. If you understand that one idea, you will understand the whole thing. And we're gonna do more examples now with stuff like that, okay? Question with this so far? And they're gonna give you a formula also that you can sort of use, but it's kind of hard to use a formula if you don't know what it means. All right, fundamental counting principles. So I said this like a long time ago, I think probably the first day of class actually. So the fundamental counting principle is just if you have like n1 ways to do the first thing and n2 ways to do the second thing, then you should have n1 times n2 ways to do both of them. Does that make sense? Does that make sense? Now, if he says there's more stuff, so like if you have 10 different shirts and you have 12 different pants and 4 different shoes, right? Then you have 10 times 12 times 4 different outfits you could make. Does that make sense? You know what I mean by that? If you're getting a salad and then there's 4 different types of lettuce, and then there's 3 different types of tomatoes, and then there's 5 other types of vegetables that you could include or not. You get what I'm saying? If we had to pick one of each one of those things, we would just multiply the numbers. Does that make sense? That's all this is saying here. Does that make sense? All right. So in how many ways could the members of the following club line up all 10 members for a photograph? N equals to this. All right. I don't like them saying N, but whatever. Hopefully there's 10 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See, I wish they picked A, B, C, D, whatever. Now she picked her kids' names. I'm actually serious. This is her name. This is her kid's name. And I think this is her other kid's name. Anyway, whatever. All right. Question is, who the hell are the rest of these people? Anyway, I gotta ask her. All right, so should be like, stop bothering. What you gonna do? How many slots? How many things need to happen here? If you line up all 10 people, what do you have to decide first? Come on, this is easy shit. If I line up 10 people, what are you gonna decide first? Thank you. That was some brain surgery. No, but it's these things are extremely difficult to start sometimes. Okay. Some things you have to make simple in your head. Does that make sense? All right. So like so if I start lining up 10 people, I mean, I don't know. I gotta decide who goes first, right? Then what would I have to decide after that? Who goes second is correct, right? Until I decide all of them. Is that right? So how many different things do I need to decide? 10. So how many slots do I need? 10. So we write 10 slots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hopefully you can count to 10, which I just did not do correctly. Okay, that's 10. Does that make sense? What do we do? What do we need to ask ourselves when we're doing the first slot? How many ways could you pick a person for the first position in the line? Is that right? You gotta start lining people up. We said that the first position represents the first person in the line. All I want to do is count this crap. Is that right? So you need to tell me then how many ways you could do that. 10 is correct. There's 10 people that you can select for the first position. Is that right? All right. What we got for the next one? 9. What do we got for the next one? Then what? What's next after that? Be careful. 7 is correct. So then this 6, 5, 4, 3. No, it sounds silly, but you have no idea how many times I've had to go through something like this in my head to make sure that I can understand it. Does that make sense? Because every time I start getting confused, you have to break it down into something very, very, very simple, start making it work, right? So these things might seem like really trivial and stupid and whatever, but when you have to do something more difficult, you will come back to this, I guarantee you. Does that make sense? Right? Because you can't go anywhere else. So no, it's just these things are important. Like I gave you these examples, I think previously about these people in my house doing work and stuff like that in the house. And like, they would do some of these things very quickly. And then some other stuff I would look at them and I'd be like, yo, just do this. You know, like, come on, let's get this finished. I'm like, you could do all this crazy stuff before and it's so complicated and all that. And now this part you got a problem with. I'm like, this part even I could do, right? And then it's because people don't realize sometimes what they're capable of doing until you start seeing it in like some sort of abstract way and being able to apply in different situations. Does that make sense what I'm saying? So like this math, that's why math sucks, because math is all abstract. So it's like, oh, let me explain to you the way that you're going to be able to use for all the different ways. But sometimes that's hard to understand at the beginning. All right. So anyway, so they do this. This is referred to as 10 factorial. That's pronounced 10 factorial. This number is 3628800 or something. That's not right. That's right. I think I made a mistake. Are you sure that's 100% correct? All right, I was right. Okay. So then so there's a thing that we got to do some talking about. Because now we start getting like rules and formulas and whatnot. All right, so n factorial is the number of ways that you can arrange n distinct items or distinguishable items. We say 0 factorial is 1 because you can arrange 0 things one way. All right, you just kind of don't do anything. Does that make sense? Like for instance, if I said to you, how many ways are there for 0 people to sit in the classroom? One way, people just don't sit down, I guess, but that is one way. Does that make sense? There ain't 2 ways. Okay. Does everyone understand what I'm saying? You get what I mean by distinguishable or distinct in this case? All right. So then the next question you should be asking is what happens when they aren't distinct? Okay. And this is also why I'm telling you to not play cards or any of these things unless you know this crap. All right. Because I'm telling you, like, you know, that's the whole game is understanding these stupid little number of ways you can do things. Does that make sense? All right, so this is 10 factorial here. So let's just go through a couple factorials for quickly. What's 1 factorial then? Which 1 factorial would be the number of ways you can arrange one thing in a line? What would that be? 1. 1 times, that's it, it's only 1. All right, what's 2 factorial? Number of ways you can arrange 2 things in a line? 2, because it would be 2 times 1. Is that right? You have 2 slots. Does that make sense? So this one's just really 1 slot. You have 1 thing. This one's 2 slots. You would get 2. Is that right? What would 3 factorial be? 6 is correct. Because you would get 3 choices for the first one, then 2, then 1. So we get 6. What's 4 factorial? 24, because you multiply this by 4. Does that make sense? Does that make sense? But if this one's 3 times 2 times 1, right? Then we gotta do 4 times 3 times 2 times 1, right? So just multiply this by 4. Does that make sense? So we get 24. You get it? What's 5 factorial then? What's 20 times 5? 100. What's 4 times 120 is correct. 4 times 5 is 20, right? We get $1.20. Does that make sense? 5 times 4 times 3 times 2 times 1 is 120. Does that make sense? Any question with this? So in a lot of math things, they'll sit there and they'll be like, oh, there's 5 factorial ways to do that. That means there had to have been 5 distinct objects that somebody was trying to line up or something. Does that make sense? You understand? Because like, if we had to do like 99 things, like I don't want to write out 99 times 98 times 97. I want to write out 99 factorial. Does that make sense? You get it? Again, the only thing that people do with these math things is just because they're lazy and they have to write it in some way that's going to make sense and be simple. So it's just some simplification. Does that make sense? Since we have to do this so often to count things. In how many ways can a male and a female be selected to decorate for a party from a club consisting of 8 members when 5 are men and 3 are women? This one's easy. This one has borderline nothing to do with anything we've talked about except for the most basic things. This one teaches me, tells me actually how good you are in addition, multiplication, and all that stuff. And I'm going to ask my 6-year-old this shit. Same question. I'm telling you, I haven't started teaching him yet. So he's still kind of dumb. But if he answers this shit correctly, I'm gonna be a dick next time. No, I'm gonna, you guys better be able to do it if my stupid 6-year-old can do this. Because he's an idiot, honestly. Try and write them out first. Try and figure out some way to write them out if you're confused. And then if you're don't want to try it that way, try and do it with slots. But don't forget, you can always rely on writing them all out. Which I think is the way that my kid would do it. I think it would take him all of an hour though. Honestly. I think you can do it in about 4 minutes. Maximum. What do you have to select first? What'd you say? I don't know what you mean. But what in order? What do you have to select first? I guess so, if we got to pick a man and a woman, right? We can start with the man. Or the woman for that matter, it doesn't really matter. But let's say we start with the man. Okay. So Sorry? The other slot would probably have to be the woman, that's true. No, that's correct. You're right, both of you. But yet, both of you have not told me an answer. 15 is correct. Don't tell me this is hard. This is just telling me if you know how to multiply this. Don't let them confuse you with this stuff. Some of the other stuff that we've been doing is probably, if I asked you this question at the beginning of class, you probably would have got it right. It's probably because we've gone through a lot of these things now and you're trying to apply some of the stuff that I've been saying so far. But really, this one is still like the beginning of this section. So this one's one of the simpler ones, actually. All right. Yep. Because, but look, but wait, you got to get the picture in your head. Okay. So like, if you say there's, so you said we want to pick men first because you're a chauvinistic man, right? So then this, no, but like, we got to pick the men first, right? So you got to pick the men. All right. So we said, I'm just making something up just so I can write something down. I'm just pretending they're A, B, C, D, and E. All right. Okay. So we could do what? A, B, C, D, and E. And then we got to pick a woman afterwards, right? So like, I don't know. Let's call the women 1, 2, and 3. Does that make sense? All right. So this one could pick 1, 2, or 3. 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 This first slot, you have 5 choices. Given the fact you selected anything the first time for the man, you would then only have 3 choices left for the woman. So we have 15. Does that make sense?
Yeah.
Question? Now, I don't think it's too hard to sit there and say how many slots we have because they're telling you in the question that we need to pick one of the first bunch and one of the second bunch. Does that make sense? Then all you got to do is ask yourself, how many ways are there to do the thing in the slot? You get it? So all I really would be expecting you to do is just 5 times 3. And this is the fundamental rule of counting. It's just like saying you have 5 condiments for your burger and you have 3 choices of bread. How many different burgers could you have? 15. Does that make sense? If you're going to use a condiment and a bread. Does that make sense? Question with this? You guys get it? Question? Counting numbers are to be formed using only the digits 4, 9. What? All right. All right, how about just that? Using only the digits, blah, 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 determine the number of different possibilities for 2-digit numbers. What you say? What'd you say? I see why you're saying 20, but I would say 25. Do you understand why? Okay. So we have 2-digit numbers. We have 2 slots. It seems like we would have 5 choices, then 5 choices. If they said we couldn't replace them, then you'd say 20. I think they intended the answer to be 20 here, but the answer should be 25. Does that make sense? All right. Determine the number of different possibilities for 2-digit even numbers. All right. This one's a little bit more annoying. So got to be a little careful here, I guess. Not completely, but a little. Why do you get 16? Where do you get 4 to the 4? Even numbers, some of the even numbers?
Yeah, 4 even.
Yeah. So if you have a 2-digit number, what if it's even, what has to be true? Second number has to be even. Does that make sense? that make sense, guys? So how many choices you got for the second number then? 4, sort of, all right? 4, I like you saying 4 here, okay? But the thing is that like, there's, actually, let's just go with 4, because the thing is that since we are saying we can't, I'm thinking that we can't replace them. Let's assume we can replace them, then it's simpler. Does that make sense? So yeah, you would have 4 choices for this. Is that correct? How many choices would you have for this one? 5, so it's 20. Does that make sense? Do you understand, guys? If I start saying that you can't pick the same thing twice, then it gets a little bit more annoying. All right? You want to do it? So let's say we have, thanks a lot, jerk. 2, 4, I'm just kidding. So then 2, 4, 6, 8, 9, it's literally probably the next question. All right, so then like this, so now let's say we, without replacement. Number of even 2-digit numbers. Does that make sense? All right, now a little bit more annoying, right? So where could we put the 9? The 9 can only end up going in the first position. Is that correct? Right? So let's eliminate the cases when we use the 9 first. Does that make sense? So then we could have a 9 and then an even. Is that right? There's 1 choice for the 9, then there's 4 choices for the even. There's 4 ways to do that. Does that make sense? Right? Then we could pick 2 evens. Is that right? There would have to be an even here. Let's pick that one first. Then we have to pick some other one here. So there would be 4 evens we could choose for the second number. Is that correct? How many would there be we could choose for the first one then? Not if we can replace them. Can't replace them. Then there would only be 3. Is that right? Because if you used one of 2, 4, 6, or 8, then I couldn't pick that again. Does that make sense? So we get 12 here. So the answer is 16. Does that make sense? Either that, or you could have taken the 20 ways that we just had and then remove the ones that are the same. So then that means you could have removed 2, 2, 4, 4, 6, 6, and 8, 8, and then you would get this. Does that, sorry? So do I, but I don't think you would have thought of it. Does that make sense? That's why I'm saying it, right? Or I think you would think of it eventually, but when that happens, I don't know. All right. I think everybody would think of all of this stuff eventually, honestly. It just takes a little while. All right. So determine the number of different possibilities for 3-digit odd numbers. All right. Sounds like it's gonna be a bitch, but luckily when they start saying odd in this case, we're very restricted then. Does that make sense? All right, so now we gotta do 3 digits here. Okay. What you think? The last one is gonna have to be one way because it must be a 9 now. Is that right? Because if it ends in a 2, 4, 6, or 8, it's even, so that's no good. Does that make sense? Good. All right. What about the other 2? Sorry? The first one would be 5. What would the second one be? 5. If we're saying with replacement, we still have 5 choices for each one. Does that make sense? The last one has to be a 9, but the first 2 could be any of the 5 numbers. Is that right? Let's just do it without replacement just because we were bringing that up before. We still have 1 choice here. How would you do the rest of this? You get what I'm saying without replacement? You get what I mean by that? You can't use some sort of repeat is correct. So in other words, use each one of these things only once. 4 and 3 is correct. Because now I've already used the 9 here. Is that right? So I would have 4 choices remaining for the first one. And then I don't know what I picked. Let's say I picked this one, then I would have 3 left over. So it'd be 12. Does that make sense? Question? Anybody with this? I don't know if I told you this before, but I used to do these math competitions when I was a kid. So one time I went to the thing, and did I tell you this and I didn't want to go? I told you the story?
Is that the one where you pick it?
This is how she figured out that I was cheating. She sat there and she's like, well, this is the chances that you did that. And I was like, yeah, you're right. You caught me. I just shut up. But you have no idea how sometimes like people think they're trying to trick others with things like this, and they just haven't ever been exposed to it. And then all of a sudden the other person is watching them and they're like, not gonna trick this one, because I don't know. I don't understand how people learn these things and they don't think they could ever be important to them, honestly. A multiple choice test. Here's another thing that this ends up being important for, right? You saw we were systematically listing out how to do a bunch of things, right? What if you have a complicated task of some sort, whatever it is, all right? And there's a lot of different ways you could do it. But you obviously at the beginning need to start deciding which is the best way to go about doing it so that you don't end up wasting your time or making a mistake or whatever, something like that, right? The first thing you'd probably want to be able to do is write out all the possible ways so you can start crossing out the ones that are bad or something. Does that make sense? You get what I mean by that? And then in a lot of cases, it's too hard to write out all the different ways because there's too many. So you start using ideas like this. Does that make sense? All right. A multiple choice test consists of 8 questions, with each question having 5 possible answers. And how many ways could the test be completed? So now you just assume you're gonna what? Christmas tree the test, right? Everybody know what I mean by that? Right? So then you're gonna write whatever on the answer choices here, right? And then based off of that, how many different possible ways would you be able to write out all these answers? Because this will tell us the chances that you got them all right. Because one of those ways is getting them all right. Is that correct? Does that make sense? All right, so how many total ways would there be to do this? If you have 8 questions and each one has 5 different answers, how are we going to try and figure this out? Way more than that. Like way more. Try and think of my slots. How many slots are there? How many things have to happen? What do you got to do if you're going to guess on the questions? What do you got to do first? What would be the first thing you have to do if you guess on the questions? I have a test right here. There's 8 questions on it. Each one has 5 answer choices. You tell me you're going to Christmas tree the test. What's the first thing you need to do? Pick the first answer. Is that right? What would you have to do after that? Pick the second answer. How many slots should we have? How many different things need to happen? 8. There's 8 different questions. Is that correct? 1, 2, 3, 4, 5, 6, 7, 8. Now what? So you go to that first question and you start trying to guess, right? How many choices you got? Cinco de Mayo. What about for the second one? How many choices you got? 5. I don't know what the damn answer is. It says A, B, C, D, and E, right? Does that make sense? You got a picture in your head what's going on here. Is that right? Yeah, but you pretend like you're taking the test. And I'm pretending I'm just gonna guess, right? How many choices I got for the first one? 5. Is that right? Does that make sense? So then it'd be 5, 5, 5, 5, 5, 5, 5. We got 5 to the power of 8. Does that make sense? What's that? 3125 times 25? I don't know what that is. 390,625. Definitely did not know that number. All right. Does that make sense? But it's not hard. You understand? All right. It does take a lot of practice though, this stuff. All right. Question?
So that number is the total.
So then when you see the kid, so like this is when I start knowing people are cheating immediately, right? Without having to do anything, just looking at them, right? I'm like, oh, that kid's an idiot. They haven't done their homework. They don't know. They haven't studied for the test. They told me they didn't study for the test. Now, miraculously, they got 100 on the test, right? And they said they Christmas treated. No, they cheated, obviously. Okay. And then, because there's a 1 in 390,000 chance that that person would end up doing that. Does that make sense? That's borderline lottery difficult. Does that make sense what I'm saying? So then then there's the other side of the coin, right? Where you have someone like me trying to get them all wrong. So now the next question they're going to ask in a second is what's the probability or what's the chances that at least one of them was correct? So you guessed on 5. What's the chances that at least one of them is correct? Okay. Does that make sense? What is that? That's 1 minus the probability that they're all wrong. The chances they're all wrong is 4/5 to the power of 8. There's about an 84%, 83% chance that you would end up getting at least one correct. If I just guess it. Okay. So this is how, now let's say I see a student like you sit there, you're generally trying, you're not going to end up getting a 0. You know what I mean? Maybe you make a mistake or something like that, but you're not going to end up getting a 0. Now, all of a sudden you come into class one day and you're like, God, I hate you. You know, like you're so annoying. Why do you make us learn this shit? You know, like whatever, right? And then the next day, all of a sudden, and you start saying to your friend, you're like, I'm gonna go and let's all get a 0 on the test. Let's all do it, right? And then I always know that there's some question on the test that's a little difficult, right? Somebody's gonna, even when they try to get a 0, they're gonna get it right every once in a while, right? So then all of a sudden you go and take the test and now you get a 0 or a 1 correct. Well, wait a second. I have all these grades from beforehand that I know that you really don't get scores like that. So now what's the chances that you get something like this? Well, even if you randomly guessed, there's not the greatest chance that you would get something like this. Oh, you tried to do this. Do you get what I'm saying? That's called statistics. Because effectively all you do is you use the data to then conclude something based off of what the data says. You know what I mean? And then sometimes you're just like, yeah, you explain to anybody, they're like, yeah, I guess so. I cheated. For any counting number, factorial, yeah, we did this already. What's 4 factorial? 24 is correct. How would you do this thing? Other than don't just tell me I'm gonna do it on my calculator. Yes, that's all you do. So all they want you to do is write out 25 times 24 times 23 times 22, oops, times 22 times 21 times 20 times 19 times whatever, it's gonna keep going. Then this is gonna be 20 times 19 times whatever, it's gonna keep going. Does that make sense? Now, a lot of times people will instead write this like this: 25 times 24 times 23 times 22 times 21 times 20 factorial. And then they just write 20 factorial here. Does that make sense what I'm saying? Because then the reason why you could do this is you're just like, done. Now all I do is multiply this crap on my calculator. Does that make sense? So it's extremely important for you to write these out this way so you can start canceling. Do you understand? Well, this is going to mean like really 20 times 19 times 18 times 17 all the way down to 1. And then the bottom, it says 20 times 19 times 18 all the way down to 1. So then they just keep canceling. Does that make sense? Well, there's no point writing all of that. I might as well just write 20 factorial and then just cancel this. Okay. All right. How would we do this one? 7. Do the parentheses first is correct. So I would just leave this thing alone or write it all out on the top. What would the bottom be then? 3 factorial, which is 3 times 2 times 1. So what would this equal to? No. Don't do fractions like that. I'm gonna kill you. No, I'm just kidding. I'm really kidding, honestly, but I want to kill whoever your old teachers were though. Because this, like, I know if these damn teachers said this, you would be doing it. All right. But instead, they start saying all this other nonsense. And it's just like, it doesn't ever explain to a person why the person needs to do fractions. All right. The only reason why you do fractions is to cancel stuff. That's it. And canceling is way simpler than multiplying big numbers and dividing big numbers and stuff like that. So let's say it was like 7 times 6 times 5 times 4 all over 5 times 4 times 3 times 2. Could we multiply these things out? We could. All right. This is like 20. This is 42. This is 840. This thing is 20 times 6. This is 120. Does that make sense? Then I could start trying to simplify this, right? And I could do 120 goes into 840, and we get this is 7 times here. We get 7. Okay. That's one option. Does that make sense? This is the option someone does when they don't like fractions or they have not been told how to use them correctly. Does that make sense? So what I want you to do is almost the same thing, honestly. But if we can make numbers smaller and simplify what we have to calculate, I want you to do it. Does that make sense? And all that means is canceling. You know what I mean? So canceling just means that if it says like A times C over B times C, that you can cancel the C's. Because if you're multiplying the top if you're multiplying by C, but then you're also dividing by C because it's on the bottom of the fraction, you're really undoing what you just did. Does that make sense? So this really, you could just simplify this. So same thing here. We just simplify this. We're like, oh, we're going to multiply by 5. Okay, but I'm going to divide by 5. Oh, we're going to multiply by 4. Oh, we're going to divide by 4, right? Then 3 and 2 is the same thing as 6. So in other words, this is 7 times 1 over 1. This is 7. Does that make sense? Now, why is that better? Because I don't want to make all these numbers bigger when I don't have to. Does that make sense? You will make more mistakes with larger numbers. You will also have to do more things than I just did just now. All right. So that's the point. Does that make sense? So when you ever have fractions and it starts saying like A over B times C over D, yes, you write AC over BD. That's true. Okay. But you should try and cancel first when you're doing this. Does that make sense? All right. And I'm picking on you, but I guarantee almost everybody would say the same thing. All right. So in this case, what I want you to do is instead of doing 5 times 4 times 3 times 2 times 1, then divide that by 3 times 2 times 1. Just get rid of the 3 times 2 times 1 first, and then the answer is just 20. Does that make sense? Yeah, because you'll end up making too many mistakes with too many things. And then honestly, that's not showing that you understand how to use fractions. And you're doing excessive computation when you don't need to. So like to do this same question here, you would have to multiply 5 numbers, multiply 3 numbers, then divide those 2 things. Try and do this one. So it's going to say error because the number is too big. I can't remember the number. I think it only goes up to like 56 factorial or something like that. But this, if you think about it my way, this is just 102 times 101 times 100 factorial over 100 factorial. So we just multiply these 2. But the point isn't just these examples. The point just is that when dealing with let's say it this way. If I have to multiply lots of things on the calculator, there's a very good chance that I'm going to make a mistake typing one of them, right? So I want the easiest way to type it into the calculator. So if I can possibly simplify what I have to type in first, before I type it in the calculator, it generally ends up being a pretty good idea. Does that make sense? But there are cases also where I can give you questions where you just won't be able to do it unless you know how to simplify it. Does that make sense? All right, and but it is important to be able to do it the regular way also. It's not that it's not. But this is part of what they want you to learn with this. Does that make sense? All right, so what about this one? How would I do this one? Do the parentheses first is correct. So this is the top one's like what? 9, 8, 7, 6, 5, 4, 3, 2, 1, right? The 7 is, well, 7, 6, 5, 4, 3, 2, 1. So I can just get rid of those right off the beginning. Is that right? Does that make sense? What else do I need to write? 2 factorial. What's 2 factorial? 2 times 1. So then this is actually pretty easy to simplify here. You just get 2 goes into 8 4 times. 9 times 4 is 36. Does that make sense? You understand? This 7, 6, 5, 4, 3, 2, 1 cancels with 7, 6, 5, 4, 3, 2, 1, and then 2 goes into 8 4 times. I know, I can tell. But you can't understand what we're going to talk about unless you understand this canceling.
I had a
Yeah.
question about the simplifying part of that. So anytime a number in the bottom.
As long as they're all multiplying and dividing. Okay? Because if I have like 3 plus 2 over 3, I can't cancel here. This is definitely 5 over 3. Is that right?
Yeah.
If you try and cancel here, it makes absolutely no sense.
Okay.
You get what I'm saying?
Yeah.
But if you start doing like 3 times 2 over, or excuse me, let's do 6 times 12 over, I don't know, 4 times 8 or something, all right? Like 4 goes into 12 3 times, 6 goes into 6 and 8 have 2 that's common with them, right?
Yeah.
So this one becomes 3 and this one becomes 4, and then we get 9 over 4. Does that make sense?
Yeah.
All right. What about this one? Well, this would be what? 26 times 25 times 24 times 23 times 22. How far am I going to have to go here before something starts canceling with stuff on the bottom? Like how much more stuff should I write here? 21 factorial, because there's going to be a 21 factorial right here also. Is that correct? Then what's this part here? N minus K? 5. So that's just 5, 4, 3, 2, 1. Does that make sense? So 21 cancels here, right? Now we just gotta cancel some of this stuff. 4 times 3 times 2 is 24. 5 goes into this 5 times. So then I guess this is 26 times 5 times 23 times 22, whatever that equals to. Does that make sense? Question?
What? That's how I do it.
All right. Distinguishable arrangements now. So previously we were talking about arrangements of things, and we were not assuming that they were indistinguishable from each other. Now, this is such a terrible way to phrase this. Now, what they want to do is they want to start talking about what happens when these things are actually not distinguishable anymore. All right. And this is where the whole division and canceling part comes in. Start trying to understand what this means a little. So if we have, let's say, A, B, C, D, how many different ways are there to pick each one of these letters one time and make a 4-letter word? So in other words, I have 4 letters here. How many 4-letter words can be made from the 4 letters, given each letter is selected only once? What would you say? How many slots do we have? 4. What do the 4 slots mean? Why are you saying 4? So the first thing you would have to do is pick the first letter. Is that right? Okay. How many choices would you have for the first one? Then what? You should have known this one already. This is just the number of ways to arrange 4 things. This is 4 factorial. Is that correct? Does that make sense? All right. If one of the letters was repeated, would there be more or less ways to construct the words? So in other words, if one of these letters is repeated, so in other words, let's say we have A, B, C, C now. So I have A, B, C, C, and now I want to make 4-letter words using each one of those letters one time. Would there be more or less ways to do so? What'd you say? It's not the same? No, just tricked you. Less. Why is it less? Why is it less? Why would there be less words that I could make that are 4-letter words if 2 of them are the same? What do you mean? No, we're still going to use all 4 letters. So like, here's a word, for instance, A, B, C, C, right? Why though, based off of these letters, would there be less ways than if based off of these letters, is what I'm asking. Because in the first one, if I do, let's say if I do A, B, C, D, right? You could switch the C and the D and you would get a different word. Is that right? Is that right? But in this one, if you switch these 2, nothing happens. Is that correct? There has to be less. Is that right? Does that make sense? Okay. How many less? Because now they want us to count how many ways that's going to happen. All right, so now this has to do with like division and stuff like that, okay? So the way we can think about this is that every single time, wherever, like, let's say this was like C1 and C2 here. Wherever I end up putting C1 and C2, I used to be able to switch them and then make a new way. Is that correct? Right? You could write like, let's say A, C1, D, C2, and then you'd be able to switch these 2 things and make another way. Is that correct? Right? So the way we want to do this or think about this is we count the number of ways that were in total before. and then we divide out the number of ways that things are gonna start repeating. All right? So in this case, there's two things here, which no longer would we be able to arrange. Does that make sense? So how many total ways were there to do this before we started messing with it? 4 factorial. Does that make sense? Now, you can no longer reorder these two things. How many ways would there be to reorder these two? 2 factorial. We have to divide out the 2 factorial ways, which is really just 2. Does that make sense? So then we get 4, 3, 2 over 2, so we get 12. Does that make sense? Now let's say it was A, C, C, C. All right. Now this one's actually easy to do without counting or doing anything. It's A, C, 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 A, C, 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 A, C, 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 A. There's 4 ways. Is that correct? Does that make sense? But you are going to get confused. You need to understand it based off of writing it out and using the formula. All right. How many ways would there be using the formula? Well, there'd be 4 factorial ways that we could do this, right? But now every single time I was thinking before that I would have been able to rearrange these things. There's 3 factorial ways that we would have been able to rearrange those if they were different from each other. Does that make sense? Or there's 6 more ways that I would be able to pick each time. So we need to divide out 3 factorial. We divide out the 3 factorial, you get 4, 3, 2, 1 over 3, 2, 1, you get 4. Does that make sense? Question? All right, so now they want to be annoying and do this with Mississippi. But it's actually pretty easy to do if you understand this rule that I'm going over. These are just the number of ways that each thing repeats. Does that make sense? So like M, there's 1 M. I, there's 4 I's. S, there's 4 S's. P, there's 2 P's. Is that correct? How many ways would there be to do this thing if they were all different from each other? How many ways would there be to rearrange the letters if they were all different from each other? Yeah. 11 factorial, there's 11 distinct objects here, so there'll be 11 factorial ways to rearrange them. Is that right? 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, right? Now, some of these things repeat, so I can't reorder them anymore. Is that right? So I can't reorder these I's. There will be 4 factorial ways that I would have been able to change them before. I can't switch these anymore. They don't do anything if I switch these. Is that correct? I can't switch these S's with each other either. There's 4 factorial ways that I would have been able to do that. The P's, there's 2. And then really, you could even write the M here, that there's 1 of these. And that's still correct. Does that make sense? Then we have to calculate what this is. We get 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial over 4 factorial times 4 times 3 times 2 times 1 times 2 times 1. 4 factorial cancels. Then 4 times 2 is 8. 3 times 2 is 6. So we get whatever this is, 35 times 990, which is 35,000 minus 350, which is 34,650. Make sure that's correct. I think that's right though. Does that make sense? Question with this? So how would I do this one? What's that? So 7 factorial divided by what? One factorial, 2 factorial. And then one more. Because there's 2 n's, there's 2 a's, and there's 2 i's. Is that right? Now, honestly, we haven't gotten to the part that's confusing yet. Okay? The part that's confusing has to do with when he starts trying to explain how to do this group stuff. All right? I'm just briefly going to mention it now, and then we'll do it again next time. All right? So they're going to start talking about these things, permutation versus combination. Permutation just means arrangements. Versus groups. They start calling arrangements permutations. And they call groups combinations. All right? Permutations, the order matters. Groups, the order does not matter. In which you put the thing into the group. Does that make sense? Let's just talk about groups first, okay? So let's say I have n total things, different things, and I want to pick groups of R. All right? Let's just make up some numbers first. Let's say n was 10. And then R is, I don't know, 4. Okay? So I have 10 things and I want to pick groups of 4. Does that make sense? So that's what? A, B, C, D, E, F, G, H, I, J is 10. But if I'm going to pick groups of 4, first thing I want to think about is how many ways could I order the 4 things? All right? Well, that would really mean there's just 4 slots. Does that make sense? So that's 10 times 9 times 8 times 7. If I could pick one each only once. Does that make sense? Does that make sense? The only problem is by doing this, I am counting too many times because what I'm saying here is I'm saying we could do A, B, C, D, and then I could also do like A, B, D, C. But these are really the exact same group. Is that right? Does that make sense? So every single time I pick 4 letters, I'm now allowing them to be reordered. Is that right? How many ways would there be that you're allowed to reorder 4 letters? If you had 4 letters, how many ways would there be that you could reorder those 4 letters? How many arrangements would there be? 24 is correct. You would get 4 times 3 times 2 times 1. You would get 24 ways. Is that right? Does that make sense? If I pick A, B, C, D, there's going to be 24 ways I could reorder those. If I pick A, B, C, E, there'll be 24 ways I could reorder those. Is that right? Each time I'm reordering all of those different ways, I really want to make them all into one group each time. Does that make sense? So I really need to divide by 24. Is that right? Or divide by 4 times 3 times 2 times 1. Does that make sense? Does that make sense? Now, the book doesn't write it out like this to teach you. Well, it does, but it writes a whole bunch of other stuff that people stop paying attention to this. But if I start saying that you have like 12 things, and I say you want to pick groups of 6, okay? And you're right, 12 times 11 times 10 times 9 times 8 times 7, because there's 6 of them. Does that make sense? And then you divide by 6 times 5 times 4 times 3 times 2 times 1. because there's 6 factorial ways that you could have reordered the things within each of the groups. So you divide out the 6 factorial many ways. Anyway, this is the way we end up doing the groups thing. Does that make sense? All right. I guess we'll go over that again next time, okay? The other 2 worksheets should be about this stuff. See, this one's about permutations and combinations, and then this one's about subtracting when you're counting or doing the complement. Remember I was saying at the beginning, it's like, maybe we should count the ways that we can't do it. Does that make sense? That's what that part's talking about, okay? Any question? About anything? All right, then I guess that is all.